In this video, we will be talking about the genomic analysis of COVID-19 as of March 27, 2020. For the full report and other COVID-19 resources, please visit the Nextstrain website. Currently, we have analyzed 1,495 publicly shared COVID-19 genomes. By comparing these viral genomes to each other, we can characterize how COVID-19 is moving around the world and spreading locally. We currently have sequences from viral isolates taken in 48 countries across 6 continents. While this data enables us to infer many useful characteristics of the outbreak and track its spread in real time, it's important to emphasize that our conclusions are limited by the available data. For example, the map shows very few sequences from the Global South. This is not because COVID-19 isn't circulating in these areas or that these cases are not as crucial to understand. Rather, we just don't have much data available from these areas. Remember that the size of each circle on the map indicates how much data is currently available from that area, rather than the true size of the outbreak. For updates in Europe, we continue to see strong mixing of samples, suggesting that the virus has continued to move across borders. As mitigation measures have time to take effect, we may see a clustering of cases by country. Now let's take a closer look. We show samples collected across Europe in the last 3 weeks, colored by the country they were isolated in. Notably, while there are some small clusters that are country-specific, there is also a great deal of mixing between isolates from different countries. This suggests that there has been continued spread across borders within the last 3 to 5 weeks. This geographic clustering might become stronger with recent mitigation efforts that curtail travel between regions. We have received many new sequences from Iceland. When it is known, we will color the map by the exposure history of each case. We see that many of these cases are from recent travelers. We're working hard to analyze all of this new data and will report our findings next week. Now, let's talk about updates in North America. Within the US, transmission patterns are complex. Samples collected from opposite sides of the country still show close relationships. Washington State has had at least 2 independent introductions, which have led to 2 separate transmission chains. There is evidence for local transmission within several states. This is clearly seen within California. Now let's take a closer look. The recent samples from Connecticut are both ancestral to and intermingled with samples from Washington State. While more data is needed to draw firm conclusions, this suggests that there has been recent transmission between even very distant parts of the country. This highlights that the transmission patterns across the US are far more complex than it is represented in the currently available data. Additional data will help us understand what is likely a deeply interconnected national epidemic playing out against the backdrop of highly heterogeneous responses from states. When looking at the cases in Washington State, we see that there are at least 2 separate local outbreak clusters. However, the 2 clusters have different origins. The first cluster is closely related to the samples from China, while the second is more closely related to the samples from Europe. It is also possible that these introductions were indirect, with unsampled cases from a different region in between. We see similar patterns elsewhere in the US. We will be taking a closer look at Northern California. There are several samples from Solano County that are sampled on different dates but very closely related to one another. While the data from California is too limited to make strong conclusions, this preliminary evidence is consistent with local transmission within Solano County. Elsewhere in the tree, we can see a similar pattern for samples isolated in Santa Clara County. These counties' cluster of cases are likely due to separate introductions based on their relative positions in the tree. Now, we will talk about the updates in Central and South America. We don't have much genetic sequence data from South America yet. Of the available data, most are from travelers. Here, each case is colored by the known exposure history. While potentially interesting patterns are starting to emerge in the non-travel associated cases, we don't yet have enough evidence to draw conclusions. Sequencing efforts are ramping up, and we will report back as the situation becomes clearer. Now, we will move on to the updates for Asia. There is evidence found for recent export of COVID-19 from Iran. Right now, we do not have viral genomes from Iran. However, we do have sequences for many cases that have reported travel there. Most sequences with travel history to Iran group together. This suggests that a lot of the Iranian cases are derived from a single introduction into Iran. Looking at the very bottom of the tree, we see a new sequence from a woman in Pakistan with reported travel to Iran. Interestingly, this case is an outgroup to other cases that we know about, but was sampled around the same time. This is consistent with several possible hypotheses. As data emerges, we'll update our analysis. Now, we'll move on to updates for Africa. The phylogeny suggests likely local transmission within Kinshasa in the Democratic Republic of the Congo for the last 11+ days. We've received new sequences from Africa this week, but sampling remains sparse. There may be more COVID activity in this region than is captured in the available data. There are new sequences from Kinshasa in the Democratic Republic of the Congo that shows evidence for several separate introduction events. Some of these sequences form a group of very closely related local cases that were sampled over several days. This is consistent with local transmission ongoing since at least March 15th, which is a sampling date of the earliest case that appears to be part of this local transmission chain and possibly earlier. The INRB's excellent work to sequence the virus from the early samples allows us to see community transmission that is hidden in many other places. In updates for Oceania, there is evidence in the genetic data for local transmission in New South Wales, Australia. The new sequences from Australia show evidence of local transmission across New South Wales. The virus has likely been circulating in this area since at least the end of February. In the next few weeks, we will be watching the European outbreaks for signs that the new mitigation measures have stemmed cross-border transmission. Secondly, we will be monitoring the situation in South America for signs of local transmission as more sequences become available. For the US, the epidemic has very complex transmission patterns of both import and spread across even disparate parts of the country. We find evidence of local transmission chains in Washington and California. We find evidence of local transmission in New South Wales, Australia. And lastly, we find evidence of local transmission in Kinshasa in the DRC. We do not yet have enough data to assess whether the virus is circulating locally in other parts of Africa. Here are some steps you can take. Reduce the number of people you are in contact with, especially if you're in the vulnerable groups such as seniors and those with pre-existing conditions. Remember that even if you're not super vulnerable, many people around you are, and you should follow these practices to protect others. Another is to try and wash your hands like you just chopped a jalapeno and have to change a contact lens. Remember to stay home if you're sick and be prepared with a few extra supplies in case you need to self-quarantine. And if you are an employer, encourage your employees to stay home when they're sick and financially support them to do so. Here are some other steps your officials can take. Examples are to make testing free and broadly available, to put social distancing measures in place, and financially support those impacted by social distancing measures. We would like to acknowledge the amazing and timely work done by all our scientists involved in this outbreak. We will report weekly updates on the Nextstrain website.